In today's video, I would like to introduce a very nice problem of Yugoslav Mathematical Olympiad edition 1975, 40 grid. Our goal, we are going to solve this following equation. We have square root inside of the square root. So for the first one, we have square root of x squared minus 5x plus 8 plus another square root of x squared minus 5x plus 6 of the square root to the power x, plus the same thing, but instead to have the plus sign, we have minus sign. And also both expressions almost are the same. The only difference between this expression and this expression is just this one will have plus 8 at the end, this one has plus 6 at the end. Okay, the whole thing equals 2 to the x plus 4 over 4 as a power. Okay, I would recommend to give the try to this problem prior getting into the solution. By the way, don't forget to support us with your like and subscribe. Now let's jump into the solution. Since we have this big expression, so the substitution is the best way to solve this one. Before I proceed with the solution, the first step we are going to determine the domain range of this equation. They don't give us even the set which I can solve this equation on. I'm going to take real numbers as a set because it's more powerful set. So without loss of generality, assume x is a real number. We have to keep inside of the square root positive. So we have to have x squared minus 5x plus 8 must be superior equal to 0, and also x squared minus 5x plus 6 must be superior equal to 0 as well. So I'm going to calculate the discriminant of this one. I will have delta equals 25 minus 4 times 8 minus 7, which is strictly inferior than 0. This one is telling us this term x squared minus 5x plus 8 is strictly superior than 0. Okay, so now we don't have to worry about this one now because it's positive. So let's check the other one. So we have x squared minus 5x plus 6 equals 0. The discriminant of this one is giving us 25. 5 squared minus 4 times 6 is giving us 25 minus 24, which is 1. So I will have the root for this one. x1 equals 5 plus number 1 over 2 is giving us 6 over 2, which is 3. And x2 is giving us 5 minus 1 over 2, which is 2, through the variation table. So we'll have x minus infinity plus infinity. We'll have the roots 2 and 3 like this. So we put in plus sign, the sign of the first coefficient a, which is plus, this is minus plus, this is f of x as a product. We are taking only the positive interval, so that means x is taken from minus infinity to 2 is included in the solution, union 3 plus infinity. This is the interval which I can solve this equation. Now I'm going to clean up this one. I'm going to start as a beginning. Now we are ready to solve our equation. Okay, we have 4 expressions are similar. So this one and this one are the same, and this one and this one are the same. So this one and this one are the same, except one has number 8 at the end, the other one has number 6 at the end. So the substitution is the best way to solve this one. So let's set capital A equals square root of x squared minus 5x plus number 8. Capital B equals square root of x squared minus 5x plus 6. Okay, the next thing that I'm trying to do now, I'm going to raise number 2 as a power for both terms. If I'm going to raise this one, I'm going to cancel out this square root from this expression. For the capital B is going to cancel out this square root because of the square. Okay, then I'm going to make the difference of these two squares. A squared minus b squared is giving us x squared minus x squared, and this term minus this term will be cancelled out because they are the same. Just the last one, it become 8 minus 6, which is 2. So if I'm going to write this one as a square minus b square, then I'm going to factor out this difference. I will have a minus b factor a plus b. The total of this product is number 2, as we mentioned before. Okay, so in the other word, this one is telling us a plus b, capital A plus capital B equals 2 divided by a minus b, or a minus b equals 2 divided by a plus b. So the next thing that I'm trying to do now, I'm going to raise number 2 as a power on both sides. Okay, now I will have the following expression. I will have a big square root. Inside of this square root, I'm going to put capital A plus capital B. Just I'm replacing this expression with number a and b. So is raised to the x for the first square root. For the second square root, I will have also a, but for this one I have minus instead plus. Is raised to the x. So for the right hand side of this equation, so equals 2 to the x plus 4 over 4. Now this equation is reduced to this expression. Okay, then the next thing that I'm trying to do now, I'm going to raise number 2 as a power on both sides of this equation. I'm going to raise number 2 as a power here. So as I'm raising the power of 2 on the left hand side of this equation, I'm going to raise the power of 2 on the right hand side of this equation as well. The next thing, I'm going to distribute this expression. I'm going to put capital A plus capital B. For the first term, I will have capital A plus capital B square to the x. This square will be cancelled out, this square root. Okay, I will be left just with x here. Same thing for the second one. I will have a minus b quinary square to the x. This square will be cancelled out, this square root too. Okay, so we'll have a minus b to the x plus 2 times is multiplied by this product. This square root is multiplied by this square root. So we'll have 2 is multiplied by capital A plus capital B factor capital A minus capital B to the x equals to this number 2 as a power. It will cancel out number 4 to the 2. Okay, I will have 2 to the x plus 4 over 2. Okay, if you take a look carefully, this product a plus b factor a minus b equals 2. This one will be replaced with number 2. Okay, then I will have the following expression. I will have capital A plus capital B plus capital A minus capital B to the x plus 2. This one I will have 2 to the x to the 1 over 2, because square root is written on the form of the power 1 over 2. Okay, equals 2 to the x plus 4 over 2. The next thing, I'm going to replace a plus b with 2 over a minus b. 2 to the x over a minus b to the x plus capital A minus capital B to the x. So this one is the same as 2 to the x over 2 plus number 1, because I'm taking number 2, I'm going to combine number 2 with this one is exponent. This one becomes plus 1 at the exponent, so equals 2 to the x plus 4 over 2. Then I'm going to move over this term to the right hand side of this equation, minus 2 to the x over 2 plus number 1. Then I'm going to take off this one from here. Then x plus 4 is the same as x over 2 plus number 2 here. I'm going to put 2 to the x plus 2 plus 1 as a common multiplier. So we'll have 2 to the x over 2 plus 1 factor number 2 minus number 1. Okay, this term is given as number 1. Then I'm going to put the substitution. Let's set capital A minus capital B to the x equals alpha. Okay, I put 2 to the x over alpha plus alpha equals this one, 2 to the x over 2 plus number 1. Okay, multiply side by side by putting alpha as a common denominator. I will get 2 to the x plus alpha square. Then I'm going to multiply both sides by alpha. I will get alpha is multiplied by 2 to the x over 2 plus number 1. Okay, then I'm going to move over this term to the left hand side of this equation. I will get 2 to the x minus alpha is multiplied by 2 to the x over 2 plus number 1 plus alpha square equals 0. And the next thing that I'm going to do now, I'm going to use the trick here by dividing this term by 2 to the 2 and multiplying this at the same time 2 to the 2. Okay, like this. I'm going to push in this number exponent inside of this one. It turns plus 2 here. Then I'm going to take off this one. This one, it will be written on this form: 2 to the x over 2 plus number 1 over 2 quinary square. Okay, minus alpha is multiplied by 2 to the x over 2 plus number 1 plus alpha square equals 0. Okay, if you take a look carefully at this expression, so this expression is written on the form of quadratic binomial, quinary square. So this one is turned 2 to the x over 2 plus number 1 over 2 minus alpha quinary square equals 0. Because if you distribute this one, is giving us this one square, which we have here, then minus 2 times this one is multiplied by this one is giving us this one plus alpha square. So I have ended with this expression. Now I'm running out of the room. I'm going to clean up this board and take this found fact at the top and move forward to next step. Previously we were working on this equation and came up with this result. So I have two facts. I have a minus b to the x equals alpha. I have this expression quinary square equals 0. Now I'm simply going to solve this equation. So this one implies 2 to the x over 2 plus number 1 over 2 minus alpha equals 0. Okay, I'm going to take this alpha to the right hand side of this equation and multiply both sides by number 2. So I will get 2 to the x over 2 plus number 1 equals 2 alpha. Okay, I'm going to cancel this number 2, which is on the right side, by dividing both sides by number 2. I will get 2 to the x over 2 equals alpha. Okay, now I know the value of alpha. I'm going to take this found fact and replace it in the above expression. So I will have a minus b to the x equals 2 to the x over 2. Okay, from here is taking two cases. If x equals 0, okay, so by replacing x with number 0, I will get a minus b to the 0, which is 1, equals 1. By replacing x with 0, I will get 2 to the 0, which is 1, which is verifying this equation. That means x is a solution for this equation. If the second case, if x different than 0, okay, so if x is different than 0, I'm going to raise 1 over x as an exponent on both sides. I will get a minus b to the x to the 1 over x equals 2 to the x over 2 to the 1 over x. As I'm dividing by x, at the exponent. That means we have to have x different than 0. That's what we have here. So I'm going to cancel out this x from exponent. This one will be cancelled out with this one. So I will be left with a minus b equals 2 to the 1 over 2, okay, which equals square root of 2. And now I found the value of a minus b equals square root of 2. So if x different than 0, so that's mean a minus b equals square root of 2. Previously we had the product a square minus b square equals a minus b factor a plus b. It was equal to 2, okay. I will get a minus b square root of 2 is multiplied by a plus b equals 2. By dividing both sides by square root of 2, I will get a plus b equals 2 over square root of 2, which equals square root of 2. So here I found two facts. I found a minus b equals square root of 2. At the same time, I found a plus b equals square root of 2. What does it mean? That means b equals 0, because a is bigger than b, because the difference of these two numbers equals square root of 2, which is strictly superior than 0. That means a is bigger than b. That means b must be equal to 0 in order to have equality here, okay. So since b equal to 0, that means because b it was replaced with square root of x squared minus 5x minus 5x plus 6, it was b, okay. Then b we found equal to, that means this one equals to 0, okay. I'm going to solve this equation. So we'll have x squared minus 5x plus 6 equals 0. By calculating the discriminant of this one, I will have delta. I will have minus 5 quinary square, which is 25, minus 4 times 6, which is 24, minus 24, which equals to 1. Then the solution, I will have x1 equals 5 plus square root of delta, which is 1 over 2, which equals 5 plus 1 6. 6 divided by 2 is giving us 3. Then the second solution, I will have 5 minus 1 over 2, which equal 5 minus 1 is 4. 4 divided by 2 is given as number 2. Okay, now I found 3 solutions, okay. So the first solution, x equals 0. The second solution, x equals 2. And the third solution, equals 3, okay. Now I found 3 solutions in integer sets. I have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in the next video. Bye.